Op-amps, non-inverting amplifier and specifications. Prepared for collaborative creation of OER by Team RC1331005. The target audience is second year, third semester engineering students. As you must be aware that there are two basic forms in which an operational amplifier can be used. That is inverting operational amplifier and non-inverting operational amplifier. As the inverting configuration and its applications has already been discussed in the previous lessons, in this section we shall focus on the non-inverting configuration of op-amps. What is a non-inverting amplifier? A non-inverting amplifier produces an amplified output signal which is in phase with the applied input signal. It uses negative feedback connection, that is, only a part of the output signal voltage is fed back as input to the inverting input terminal. The high input impedance and low output impedance of the non-inverting amplifier makes the circuit ideal for impedance buffering applications. Let us take a look at the circuit of a non-inverting amplifier. As we see that the input signal is applied to the non-inverting input terminal designated as plus. The inverting input terminal designated as minus sign is connected to the ground via resistor R1. A second resistor R2 is connected from the inverting input to the output. Since it is connecting the output to input, it serves as a feedback path. What we observed in the circuit was that the output voltage is potentially divided across resistors R1 and R2. Let us consider a case when the non-inverting input is connected to ground, that is V input is 0 volts. The voltage at the inverting input terminal must also be at ground level. Any voltage difference between the input terminals would be amplified to move the inverting input terminal back to ground level. This happens due to the concept of virtual ground, which shall be dealt in a short while. Since the inverting input terminal is at ground level, the junction of resistors R1 and R2 must also be at ground level. This implies that the voltage drop across R2 will be 0. As a result, the current flowing through resistors R1 and R2 must be 0. There is 0 voltage drop across R1. Therefore, the output voltage is equal to the input voltage, which is 0 volts. Now let us consider the second case when a positive going input signal is applied to the non-inverting input terminal. The output voltage will shift to keep the inverting input terminal equal to that of the input voltage applied. Hence, there will be a feedback voltage across resistor R2, and the current flowing through R2 is given as I2 V out minus V in, which appears in the inverting terminal as well, divided by R2. Here I2 is considered as the current that is flowing across the junction of resistors R1 and R2. The current through resistor R1 can be expressed as I1, which is V in this side and ground this side. So V in divided by R1. Hence we can say that V input is I1 times R1 and V output from this equation is I2 times R2 plus V input. Once we have obtained the expressions for output voltage and input voltage, we can write down the closed loop voltage gain of the non-inverting amplifier as the ratio of V out to V in. Just putting in the expressions for V out and V in, we obtain that the closed loop gain ACL is 1 plus R2 upon R1. This happens because I2 and I1 are same. The above equation is positive, indicating that the output will be in phase with the applied input signal. The closed loop voltage gain of the non-inverting amplifier is determined by the ratio of resistors R1 and R2 used in the circuit. Practically, non-inverting amplifiers will have a resistor in series with the input voltage source to keep the input current same at both the input terminals. Now we come to virtual short. In a non-inverting amplifier, there exists a virtual short between the two input terminals. A virtual short is a short circuit for voltage but an open circuit for current. If you remember, we discussed virtual ground, a term, in the earlier slides. In electronics, a virtual ground or virtual earth is a node of circuit that is maintained at a steady reference potential without being connected directly to the reference potential. The reference potential is considered to be that of surface of earth, hence the node is called ground or earth. Here, it is important to say that virtual short is the generalized concept of virtual ground. It uses two properties of an ideal op-amp. First, the input resistance is infinite, hence the input currents at both the terminals is zero. And second, the open loop gain is infinite. So the difference voltage is always zero. Although virtual short is an ideal approximation, it gives accurate values when used with heavy negative feedback. As long as the op-amp is operating in the linear region, the open loop voltage gain approaches infinity, and a virtual short exists between two input terminals. Because of the virtual short, the inverting input voltage follows the non-inverting input voltage. If the non-inverting input voltage increases or decreases, the inverting input voltage immediately increases or decreases to the same value. This action is often referred to as bootstrapping. Here we close the section. The references for the slides are Chapter 10 of Electronic Devices and Circuit Theory, 10th edition by Robert L. Bollisted and Louis Nashelski. Non-inverting operational amplifiers from www.electronicshub.org, and Chapter 8 of Electrical and Electronic Systems at Pearson's Education Limited, 2004. Thank you.